Data. So in this presentation, we will have 4 units. First, we will discuss the fundamentals of data analysis, including definitions, characteristics, and the concept of the digital footprint. Next, we'll cover the importance of the data analysis, its applications and duplications. We'll also explore career choices in data analysis, and you will see that there are lots of careers nowadays based on the data that is produced on a daily basis by everything, Internet of Things, Internet of Everything. We have also ethical consideration of analyzing data. As you know, many of these companies like TikTok or Meta, they have our data and they analyze the data, maybe behavioral data, and they do what they do. So we have also ethics in there. We might not think about it, but it really exists. Finally, we will learn about advanced topics such as machine learning and artificial intelligence. Okay. So next slide. Let's go to definitions, characteristics, and digital footprint. So data analysis involves examining, cleaning, transforming, and modeling data to discover useful information, draw conclusions, and support decision-making. So it's not just data. It helps us to decide about something. It uses statistical, algorithmic, and visualization techniques to turn data into insights, identifying trends, patterns, and anomalies for strategic planning. For business, it might be strategic planning. For healthcare, it might be something else. For technology, it's different. And it is really important for individuals as well as organizations. So this is just a basic introduction. There are many ways to say what is data analysis, but this is one of the things that exist out there. So what is drive decision making? Data analysis helps business and organizations to decide based on evidence. So evidence is data, okay? So you analyze the data and you decide using that evidence. Enhance customer experience. You get feedback from your customers. You try to understand what your customers like. You have loyalty cards. You analyze the data. You know where they live. Do they live in the city? Do they live in the urban area? And then you try to understand how that affects the way they buy things, how regular they buy things. Sometimes you have to see, for example, predict trends. How do you measure trends? How do you measure efficiency? Innovate and compete. So you try to measure something, you see some trends, and then think, okay, let's do this in a different way. And in order to be competitive. And at the same time, mitigate risk, personalization. As we all know, we think of traveling to Hawaii, for example, and the next moment, for some reason, for some magic reason, we have adverts for promoting Hawaii and hotels in Hawaii. It means that they have some kind of data. They analyze that data. Maybe sometimes it's not ethical. And then they come up with an advert. And then you think that, okay, are they following us? Maybe they are following us. Maybe not. But for sure, they are doing data analysis in an advanced way. Okay. So many, many years ago, all customers had all these papers, and you could find in old shops, you had one paper that they were writing down who bought what. So that was the most ancient data analysis type, and we knew that this customer bought these things based on the paper we had. Now we have databases, we have financial documents, we have employee records, and we have so many other things here. So internal company data, customer-generated data, customer feedback and reviews. We have survey responses, customer service records. Okay. So internal company data, it's important to help companies to understand how they work, to understand how much stock they have, to see if you have heard about before first in, first out regarding their stock, for example. So it's important for them to understand what are the trends, what is selling, what is not selling, and predict that in 3 weeks we will need these new parts, but we have to order them now, because in 3 weeks, it will take 3 weeks for the ship to come from China or wherever, okay? So again, it's data analysis, but different kind of data analysis. Predictive data analysis, because Christmas is coming, Halloween is coming. It's a different. That is for business. For researchers, it might be different. We have machine-generated data. We have millions of sensors and IoT devices connected to the internet. Now we have, everybody's got a wearable. For example, I'm getting my heart rate every minute. Every minute, it analyzes, it gets average of my heart rate. I get alerts if something goes wrong, and for all those that they have the Apple Watch, it even it analyzes data in a much better way, and sometimes people were saved because they were having a stroke and didn't realize it. It means that you have on this thing now at the edge, analyzing data, and it helps you, it changes your life. Okay, if some people didn't have this, then maybe they would have died. So telematics, so we have smart alliances. We have web traffic data. I hope they will do something in Nicosia regarding smart city and smart traffic, and I hope in the next couple of years we will have less traffic in Nicosia. Okay. We have government databases, public records. We have data coming from that we can use in Google Analytics. There are so many data, so much data everywhere. But one of the important things is what to do with data. What kind of data it is? Is it structured data? Is it unstructured, semi-structured? Is it quantitative, 5, 10, 20? Is it qualitative? Is it good? Is it bad? Is it green? Is it red? Is it time series? What is time series? Imagine that in one of our projects that we're running, we were getting data 20 times per second. Okay, 20 times per second, and for multiple sensors. We had to analyze that data. Okay, so, and then if we wanted to go back, what was the measurement at that point of time? It means we have time series data, cross-sectional data, big data, transactional data, web data. Still, everything is data, but different kinds of data. Okay. So we have structured data, as you can see here. It follows a schema. We usually found this in Excel files, in SQL, CSV files, comma delimited files. They are easy to search and organize. So it's just, let's imagine them as tables. Okay, let's imagine these as tables, which is the most usual for us people to understand. Okay. Now we have unstructured data. Unstructured data, it's not easy to be conceived by human beings. So it's important for us to use various tools because from first glance, we don't really understand what are the relations between each table, multiple table, 3-dimensional, 4-dimensional, multi-dimensional databases are used, or non-relational databases are used. We have discrete versus continuous data. Qualitative data. That was a great movie. It means qualitative data. Quantitative, continuous data. Okay, as I mentioned before, we have also discrete data. The number of employees in a company, the number of cars passing through a toll booth, the number of questions on a test. These are examples of discrete data. Okay, so you count them. Continuous data. The height of students in the classroom. The amount of time it takes to complete a task. So these are continuous data. Okay. So continuous data are usually represented by measurements, and it can have an infinite number of values, okay, because it's continuous data. Every second, every minute, every hundredth of the second, every millionth of the second. Okay. So one of the use cases is in cases where precision is important, such as time, distance, and temperature. And now we have, I think most of you will know, different primitive data types: integer, floating point, double, character, Boolean, which is true or basically true or false. We have strings, we have structure, etc. Could you please raise your hand if you have heard any of these things before? If you know any of these things, please raise your hand. I'm just trying to understand. Okay, so I see most of you here know about these things. There are a couple, but there are still a couple of people here that they haven't heard about this. Okay, not a lot, but still. So as you understand this, if you done data analytics, then you should know about these kind of things. Okay. So one of the main problems I see in data analysis is the actual data. It's the source of data. Many times we don't care about how the data was acquired, if we have noise in the data, how much noise we have in the data, if we have interference in the data. And we try to, and we put that thing in a machine learning or whatever program and software to analyze that thing. And then we get back with erroneous results, with results that they don't really represent what we think of, what we expect. If you go back to, I would say, the older generation, because we have lots of memory limitations, RAM limitations, CPU limitations, and you had to count everything. So do we need to measure these things every second, every 10 minutes, or every 1 hour? Okay. So we instantly might have much less data. So when I was helping a friend of mine, much younger one, to do this, people tend to acquire data to the maximum speed. So if the maximum speed of the data acquisition card, for example, is 10,000 points per second, they try to acquire at that point, and they say, hey, I will get better data if I acquire 10,000 points per second. But that doesn't mean anything. If you measure temperature might need 30 seconds to change. So instead of acquiring 2 points per minute, you acquire, I don't know, a couple of hundreds of thousand points per minute. And then you try to export that thing in a database to analyze that thing. And then your computer is struggling to analyze that. So it's really, really, really important to think about the purpose of the analysis, what you want to get out. Does my value change a lot? How many times per second does it change? How many times per hour does it change? For me, this is the important thing. It's like trying to cook something and your raw material is bad. I mean, if you get bad meat, if you get bad, everything is bad. Even if you are the best chef, you will not get a good food at the end. So please make sure that the data that you get is exactly presented at the correct data rate, at the correct accuracy. They are reliable, they are relevant, and they are complete, okay? For example, I was reading a couple of days ago, and you know, this ChatGPT and other from Google, that they basically try to analyze all data that exists in the internet, put them in a LLM, long language models, and analyze everything and come back with useful ideas. And Gemini, I think it was Gemini from Google, some people were asking there, how can I make the cheese of the pizza to stick better, okay, on the bread? And because the stupid Gemini or whatever software, they didn't filter the data that was input in the LLM system, there was a joke somewhere in Reddit, and someone wrote somewhere, and he got hundreds of likes, dozens of thousands of likes, that if you put glue, okay, if you put glue and then you put the cheese on the pizza, then it will stick better. And if you ask Gemini, then this was the answer, one of the answers it was given. Why? Because those guys there, they said, Reddit is good, Reddit is okay. Okay, let's filter it, how many likes it got. If it got too many likes, it means that it's correct. It doesn't mean anything. It was a funny thing that we people understand, the machine does not understand. It got 10,000 likes, but it got 10,000 likes for the wrong reason. So you got the idea, okay? It doesn't mean anything. So we might expect something else. So first thing to do is know your data, understand your data, filter your data, okay? Otherwise, even if you have the best machine, if you have the best code, you will end up with meaningless results, okay? This is for me, this is number one. And then you have different kind of tools. You might have Python, you might have Excel, you might have Amazon, AWS, you might have whatever, okay? If you have a bad data, even if you analyze them with the most expensive, the best, whatever, it will get you, again, stupid things at the end, okay? I'm just exaggerating with the glue thing, but I was amazed that it happened, okay? It should never happen, but you get the idea, okay? Consistency, granularity, accessibility, interpretability, integrity. So what is consistency? The consistency is the necessity for data to be coherent and compatible across different data sets and over time. Okay? Granularity, the level of detail within the data, allowing for more specific analysis. So there are many things here that we can say about what is consistency, granularity, accessibility, etc. In any case, it's important to have data in a way that will help us integrate our data with other data in a useful way. Okay, but there are many terms here, many parameters here that they say what is good data and what is bad data. Okay. And now we have challenges, many challenges in data analysis. Some of the challenges are data quality and integrity, volume and complexity. Also, we don't have people that we don't have people that understand about data. They just put everything in a magic box. They press the button, but they don't realize, is this logical? How can I make it better? Okay. And so what we have here, data quality and integrity means that we might have errors in the data. We might have outdated information. Volume and complexity. If it's a very large database, how can we process it? We need different kind of methods. New processing methods, new software, new Python tools, new tools, whatever tools. As I mentioned, we have this skills gap, and then we have other kind of data. What does this mean? We have our own data, but we have data that we need in our research from this source, from this source, from other source. So most of the times, we have to combine our own data with other data that others have done in the past. So let's go back. So in the 17th century, it began with statistics. So we had a lot of mathematicians doing this data analysis. So data analysis, it was closer and still very close to mathematicians, I would say, albeit nowadays it's important for everybody. If you're an engineer, if you are a psychologist, if you are a politician, to understand what are the flows and what are the changes based of on your presentation or how you present to the world, if you have social media. In the 20th century, okay, we started in the mid-20th century, we started having computers, we started to have databases, and now we have, on the 21st century, we have big data, machine learning, artificial intelligence. So this involves a multidisciplinary approach, not only mathematics, but also physics, biology, many other things, okay? So there are many open tools, for example, in Python, R, etc., that are quite popular nowadays for analyzing data. And lots of companies nowadays, they rely on these decision tools for data analysis and especially real-time analysis. Maybe you know about the cryptos going up and down and when to buy, when to sell. Everything is data analysis nowadays. Prediction tools, models, to create a model there to follow this and do that, if this, then that, based on the depth. So let's go to the next one. Next one. So data analysis is really important for informed decision making, predictive power, and efficiency. It helps trends, optimize operation, and save costs. So, and now we have the so-called 4 V's. Volume, the volume of the data. Velocity of the data, how fast the data is acquired. Variety of the data, different kinds of data. Name, location, temperature, how you feel, many other things. Veracity of the data. Veracity of the data, as you can see here, veracity is ensuring data accuracy and reliability to avoid misleading conclusions. So this is one of the important things that we have nowadays, veracity. Okay. One moment, please, because I press twice, maybe. So nowadays, this is something typical we have. We have Internet of Things devices, we have servers, we have storage, filter bad data. When we have a project called Quiet City, sometimes for some reason we were getting some spikes of, instead of measuring 60 something decibels for noise levels, we're getting 120 dB, which is beyond close to the threshold level of how much we can hear. Why? Because there was somewhere electrical noise somewhere in the sensor, and we're getting 120 dB, which was the maximum of the sensor, but there was no actual noise. So we had to filter that stupid data and get it out because it was just noise. If we had it there, then it will say that our space is noisy and it's dangerous, and the average will be very high. So filtering data is really important. And also we have now, as you can see there, cloud storage and on-premises storage. Cloud storage in Amazon, in Google, in Azure, and they are very expensive. Okay, so we have to be really careful when we upload anything to these companies, because they might have the right tools there, but they charge a lot. So we have to be careful what kind of data we upload there, or otherwise, if we don't care about how much money we will pay, we just pay them and whatever happens, happens. Okay. Let's go to the next one. This is one of the most important things. So when we design, let's say, a database, we think of, okay, let's do this analysis, and then, okay, what do you do with the data in 1 year? Do you still need it on a solid state disk in NVRAM? Do you still need it there? Do you still need that in your Excel file, propagating and getting longer and longer and longer? Okay, so we have this life cycle of data analysis. So we have, you can see there, the collection, data processing and cleaning, analyzing. We visualize then our data. After we visualize the data, we interpret the data. Based on the interpretation, we make decisions, we take actions, and then based on the action, we say, okay, now we have taken the action. Let's say again what happened with the data if we get something new. Okay, so all data have their own life cycle, and when we design some things related to fast data acquisition, collection, data analysis, processing, actions, etc., we always have a multi-layer approach. So we have a fast processor for acquiring data. Then we save the data temporarily in NVRAM or somewhere where it's very, very, very fast. Okay, we analyze it, we take action, decisions, and then we store it in slower hard disks, and if not needed, to cold storage. Okay. Please, if you have any questions. Να κάνουμε διάλειμμα σε κάποια φάση. Okay. Okay. So is this clear? Okay. So does anybody know Excel? Yes. Any other statistical software? Please raise your hand. If you're using a statistical software, please raise your hand. Please go. Okay. Programming languages? Okay. Okay. Interesting. Okay. Okay. So there's no solution one fits all. Okay. Everybody has its own tools. There are many programming languages. Some are better suited for engineers. Some might be better suited for computer geeks or software developers or guys that they know very well programming. And what about data visualization? Okay. Okay, MATLAB. It's for engineers, let's say. Okay. So there are dozens of solutions out there, okay? Okay. Everybody knows Excel. It's powerful, but it might give us an idea of what is happening, but as good as it gets, it has its limitations, okay? So I don't want to say a lot of things about this. It's good just to get an idea, to aggregate your data. If your data is in a CSV format, in another format, I would say that it's good in trying to understand if you have any noise in the data, to remove it, to prepare your data. So I would say that, and many times I use Excel to prepare some of our data, to remove some things that I don't want. Okay, but that's it. And some macros and some other things are not really really efficient compared to other tools, but it's there. SQL, who said that is using SQL? Could you please tell us how you use it? Okay, so you have a database, you write queries, and then you ask the database about some things to filter them, sort them, display them, etc. Okay. Any other databases that you use out there? Only Microsoft things? MySQL, Maria database, Mongo database, Influx database. Okay. So for us, for example, in on the product that we run, we use Influx database, which is time series database, because we have something like 500,000 points per hour. Okay, so for relational databases, it's easier to do things. If you start getting dozens and thousands of points per second per minute, then you have to move to different kind of database and different approaches. Otherwise, SQL databases will just die, or try to get a result out and will take them hours. Okay. And then we have Tableau. Do you know Tableau? Yes? Okay. Okay, the Tableau is, I would say, quite easy. It's a step up compared to Excel. It has its limitations, but it is good in for visualization to understand what kind of data we have there, and try as human beings understand the connection of our data, connecting our data. Who has used Tableau before? Please raise your hand. So, okay, 5 people, 6 people. Okay. How did you use Tableau before? No. Okay, which was easier compared to Excel? Much easier compared to Excel. Much more fun, and you can drag and drop and move things around and create charts that in Excel it takes a lot of macros and if that and many other codes that you don't really know or remember.